Welcome back at C Square. In this lesson we'll talk about kites, and you notice here a kite is a quadrilateral with exactly two pair of adjacent congruent sides and no opposite sides congruent. So you see that in the picture here, these two consecutive sides are congruent, these two consecutive sides are congruent, and no opposite sides are congruent. You see the same statement right here. So what is about the kite? We have these properties. The diagonals are perpendicular. Exactly one pair of opposite angles is congruent. Exactly one diagonal bisect opposite angles, and exactly one diagonal bisect the other diagonal. You see all these properties here. Diagonals are perpendicular. You can see the right angle right here. Exactly one pair of opposite angles is congruent. That is these two angles. Okay, so these are the angles formed by the non-congruent sides. Exactly one diagonal bisect opposite angles. That would be this diagonal AC bisect angle BAD and BCD. We can see that in this picture. These two angles are congruent and these two angles are congruent. And exactly one diagonal bisects the other diagonal. You notice diagonal AC, the one that connects the non-congruent angles, bisect the diagonal that connects the vertices of the congruent angles. Now let's use this property in the next problem in this example, and we have to find the measure of numbered angle. I'm going to start with angle 1. Angle 1 is the angle that is the same with this angle. The measure of angle 1 is 94 degrees because angle B and angle D are congruent. These are the angle formed by the non-congruent sides. Let's take a look to angle 2. How am I going to find that? Remember, this is a quadrilateral, so the sum of the measure of the interior angles for this quadrilateral will be 360 degrees. So now I'm going to say here the measure of angle A plus the measure of angle B plus the measure of angle C plus the measure of angle D is 360 for angles. We know angle A, it's 102. We know angle B, we just found out that is the same with angle 1, 94 degrees. We need to find the angle C, the one that I call it angle 2, and the angle D is given to us is 94. So that would be equals 360. So now I'm going to add these three numbers which represent the angles. So we have 102 plus 94 plus 94 again. That will be 290 plus the measure of angle 2 equals 360. So the last step is to subtract 290. And we have the measure of angle 2 is 70 degrees. And the angle 1, 94 degrees. So this is about this example that is covering a kite. On the second example, we still have a kite. We can notice this two congruent sides, the other two congruent sides and the opposite sides are not congruent. So we have a kite. So we need to find the measure of the number angles. And the angle 1, the first one here, it's a 90-degree angle. Remember, the diagonal of a kite are perpendicular. The same property as a rhombus or square. So angle 1, very simple, 90 degrees. Angle 2, this one here, if you notice angle 2 and is in this triangle A, let me call it T here, ATB, which is a right triangle. So that means angle 2 and this angle that is 46 degrees are complementary. So let me write that, the measure of angle ABT, let's call it like that, plus the measure of angle BAT is 90 degrees, because those two angles are acute angle in this right triangle. ABT is nothing else than angle 2 plus the measure of angle BAT, that will be 46 degrees, equals 90 degrees. So we're gonna subtract 46 and we have the measure of angle 2 is equals 44 degrees. Okay, so we finish angle 2. We need to find angle 3, this one right here. Now, for that reason, I'm looking to this angle. This angle here is going to be 34 degrees because the diagonal AC is the diagonal that connects the vertices of non-congruent angle, bisect these two angles. Okay, so this is 34, and again this is a right triangle here. So the measure of angle 3, I can write a very similar statement to this. The measure of angle 3 will be nothing else than 90 minus 34. So the measure of angle 3 will be 56 degrees. Okay, so we use the property of the kite in this problem. The next one, very similar. The only thing, we're going to have to write some algebraic equation to solve and find the values of the variable. And we have x and y here. And the first thing, I notice what? This angle B and this angle D, if you remember, these are the two angles that are congruent. I used this one just a couple minutes ago. So they have the same measure, which basically gives me now the equation that allows me to find x, 3x plus 5 equal 4x minus 30. Okay, so here I'm going to subtract 3x, but of course you can do it in a different way. Subtract 3x on the other side of the equation, and we have 5 equals x minus 30. I'm going to add 30, obviously, on both sides, and we have x equals 35. And we need to find y. Right, let's take a look to y now. And for that reason, we're gonna find the measure, let's say, of angle B. The measure of angle B is 3x, 3 times 35 plus 5. So 3 times 35 is 105 plus 5, that will be 110 degrees. Okay, so how can I use this guy now? I can use, because this angle B plus this angle plus this angle, they are in a triangle, in the triangle ABC, their sum should be 180. So let me write that here. The measure of angle BAC plus the measure of angle B, we can just simply call B, right? Plus the measure of angle, don't call it C, BCA, it is 180 degrees. Those triangles are in the same triangle ABC. So now we have the measure of angle BAC, that will be 2y minus 20. Plus the measure of angle B, we did find out that one, remember, it's 110. Plus the measure of angle BCA, which is just y, equals 180. So you notice now we have an equation. 2y plus y here, that will be 3y. Negative 20 plus 110, that will be plus 90, equals 180. we're gonna subtract 90 here on both sides, obviously, and we end up with 3y equals 90, and the last step, divide by 3, so we have y equals 30. And that's it for this problem. And let's move to the next one, where again we have a quadrilateral that is a kite. Again, we notice these two sides are congruent, these two sides are congruent, and the opposite sides are not congruent. So this is a kite. So we need to find the length of AB. If you notice, AB is this side of this kite. We know this is 6, this is 8, and what else we know? This is a right triangle because the diagonal in a kite are perpendicular. So we have a right triangle. Six, 8, and I'm gonna call this one x. What can we use in a right triangle? The a squared plus b squared equal c squared, Pythagorean theorem. Be sure a and b are the legs, so 6 and 8. So we have 6 squared, that will be 36, 8 squared is 64, equals x squared. 36 plus 64 is 100. And for finding x, we're gonna take square root as the inverse operation, and that will be 10. That x, remember, is nothing else than AB. AB is 10. It's useful if you remember a Pythagorean triple, 6, 8, and 10, then you don't have to do this Pythagorean equation, these steps. And now in the part B, we need to find the perimeter of A, B, C, D of that kite, right? So remember, this is 10. This is 10. We need to find how long it is, either BC or DC. So again, a right triangle. Let's say we're gonna do this one, and we have 8 and 15 here. Let's see how much this x is, but I want to be sure it's a different x. So again, with the same setup, a squared plus b squared equals c squared, and we have 8 squared plus 15 squared equal c squared, 8 squared, or x squared in fact. So we have 64 plus 225 equals x squared. 64 plus 225, it's 289. And for finding x, we're gonna take square root of 289, and that will be 17. Again, this is a Pythagorean triple. In case you remember, that will be useful. 8, 15, 17. In our case, that will be how much BC is. BC is 17. But this one is also 17. So now, what is the perimeter? We need to find out. It's twice AB, because AB and AD are congruent. So twice 10 plus twice 2 times 17, since BC and DC are congruent. That will be 20 plus 34. That will be 54 units for the perimeter of this kite. What about rectangular grid? We can look to kites like any other quadrilateral in a rectangular grid. We have this quadrilateral which says we need to determine if it's a kite, and we notice the coordinates are negative 14 and 2, 4 and negative 6, B, C 6 and 2, and D 4 and 10. So the first thing I will do is to plot the points, even though that those numbers are not very small. But look at here, I did it. I went by 2. I noticed this number all are even, so you may want to do that just to get a picture. Now, if you take a look picture, it looks like these two guys are congruent, and these two guys are congruent, right? But again, you see, I said it looks like. We need to justify. So how can we justify? Okay, we need to find the length of this segment. So let's start with the first one, and you notice I'm gonna draw this triangle, and I'm gonna count 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, you can call this 9, or since it goes by 2, you can call 18. It doesn't matter too much, but to make the math easier, I'm gonna say 9, even though it's 18. And this one is 1, 2, 3, 4. 4, but like I said, in fact, is 8 units. So can we find the length of that segment AB? So remember, we used this already, Pythagorean theorem. So we're gonna do the same thing. A square plus B square equals C square. See, okay. So we are gonna have here 9 square plus 4 square equal x square. So we have here 36 plus 16, I'm not 36, I apologize, that is not 36, is 81. 81 plus 16 equals x squared. 81 plus 16 is 97. Which means AD is square root of 97. And I'm not gonna even do anything else. I'm gonna look now to AB. If you take a look to AB, we're gonna have the same triangle. The only difference now is this bottom part, but this is 4 also, right? So pretty much the same math, and we're gonna end up with AB being square root of 97. Which means AD is congruent with AB. Now let's take a look to the other two. And to the other two, let's take a look. Okay, a very similar triangle. This one, right? 4, and this is 1. Okay, and again, this is x again. A squared plus b squared equals c squared. And we have 4 squared plus 1 squared equal x squared. 16 plus 1, that is x squared. Now x squared will be 17 in this case, so x will be nothing else than square root of 17, but x in this case is BC. Okay, now if you take a look, the second triangle, which is this one, the bottom one, is going to have the same thing, 4 and 1. So obviously we notice now, in fact this was DC. We notice now we can do the same math, and we get that BC is square root of 17, which means DC is congruent with BC, which is what we were looking for. And also you notice that the opposite sides are not congruent. So now we know A, B, C, D is a kite. Now you notice the diagonal are also perpendicular. That will be a good thing, but however, that is not good enough to prove this quadrilateral is a kite. It can be also, remember the diagonal of rhombus are also perpendicular. So you have to prove using this way. In my last part of the lesson, we're gonna look to some proofs. And in this one, we know that MNPR is a kite. Moreover, it tells us that MN congruent to MR, and NP congruent to PR. We need to prove that MP is perpendicular on NR. So we need to prove that this is a right angle, for example, or any other angle. So how are we gonna do this? How we're gonna prove this theorem? How we're gonna prove that the diagonal of this kite are perpendicular? We really have to find a way, okay, to get these triangles. So let me think a little bit, because I didn't think yet. These two triangles are congruent, so we know these angles are going to be congruent, but that is not good enough. These two angles also are going to be congruent. If these two angles, okay, this is a common side, so yes, then these two angles are going to be congruent, and this, okay, are going to be congruent. So it's kind of a long proof, but it's doable. Let's start from the beginning. Okay, so first of all, we're gonna prove that this triangle that contain these four sides, right? So the triangle MRP and MNP are congruent. So how are we going to do that? We start from the fact that MN congruent to MR, and that is given. Then we have NP congruent to PR, again given. And also we have MP being a common side, so that will be the reflexive property. Okay, reflexive property of congruency. From these three statements, we can say that those triangles are congruent, like I said. Triangle MNP congruent to triangle. Now let's be sure we put the corresponding parts MRP. And the reason will be simply side, side, side postulate. Now, because these triangles are congruent, then we know these two angles should be congruent. Those are the corresponding two angles. And these two angles need to be congruent. So I think I'm going to use just these two on the left. So I'm going to say, therefore, angle NP congruent to angle, let's be consistent, RMP. And that will be because corresponding parts of congruent triangles are congruent, CP, CTC. Okay, so now we're going to move in two other triangles, this one, and again we know these two are congruent, these two are congruent, we prove it, and this is a common side. So those two triangles are congruent by side angle side. So let's do that here, and Now I'm going to do a 2-column proof. Okay, let's do both ways, so you can be familiar with both. Statements, reasons. Okay, so now we're going to start again with Mn congruent with Mr, which is given, right? Then we're going to say M, and let me call this one T. I think we can do that, right? MT congruent with itself. So again, we used that property just a minute ago, reflexive property of congruency. And now we're going to bring those two angles, we have them here down, angle NMP congruent to angle RMP. And I'll say here the reason is C below. So now we know what the two triangles I mentioned, triangle M and T, congruent to triangle MRT, and like I said, let's be consistent, and the reason will be side angle, side theorem. Okay, but now because of that we can say about these two angles are congruent. Angle NTM congruent to angle RTM, and that will be corresponding parts of congruent triangles are congruent. But also these angles form a line, they are supplementary and they are congruent. So by the way, let me write that here, the measure of angle NTM, we're gonna need that, is equal with the measure of angle RTM, and this is definition of congruent angle, right? Okay, and also, like I said, the measure of angle NTM plus the measure of angle RTM is 180 degrees, and this is definition of linear pair. Okay, pretty. Okay, getting closer to the what we need to do. Now we can use substitution. We can do from here. We do a substitution either one. So let's say we put NTM here. So we have twice the measure of angle NTM, right? Equals 180 degrees, and I use the substitution, right? Property. Then I will divide by 2 and get the measure of angles NTM equals 90, and that will be the division property of equality. And now that tells us MP has to be perpendicular NR, because this is the definition of perpendicular line. This is the sign of perpendicular lines. So yes, we did this proof. You see both. We see a little bit of a flowchart and a 2-column proofs here. And the last, in fact, it's not the last. Another proof here. We have MNPR is a kite. Again, we see MN congruent with MR. And P congruent to PR, we need to prove that NA is congruent to AR. I think we just did that in the previous problem. If you remember, we're gonna prove that these two angles are congruent first, and then we can use the triangle. So one more time, it's gonna be pretty much the same thing. MN congruent with MR, that is given RP congruent to NP, again that is given, and NP congruent to itself, and that is reflexive property. From these three, we have what we need to prove that those two triangles are congruent. What triangles? Triangle MNP congruent to triangle MRP. And now let's change a little bit here. All right, let's mark these two angles instead of the other way. We can do either way. So from this fact, we can say, oh, and this one will be side, 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 right? The reason. And now from this statement, we can say those two angles I mark NPM. It is congruent to triangle RPM, angle RPM. And the reason we use it before corresponding parts of congruent triangles are congruent CPCTC. Okay, so now these two angles are congruent, these two sides are congruent, this is a common side. Okay, and then the triangles, this one and this one are congruent. So that will be right here, and then let's do two column proofs now, like we did in the previous problem. So probably I should have done this problem first. Statements, if you remember. Reasons. And like I said, we're gonna start with NP congruent to RP or PR, and that is given. Okay, then we have AP congruent to itself, reflexive property, and then, like I said, the two angles I mark, angle NPA. In fact, let's be consistent, NPM congruent to angle RPM. And I'll say here C below. Those are the reason. Okay. And now we can say about those two triangles, like I said, like I marked them, triangle NPA congruent to triangle RPA. And the reason is side angle side theorem, right? And based on this, we have now what we need to prove, that NA congruent to AR based on corresponding parts of congruent triangles are congruent, CPCTC. Okay, so like I said, probably this proof is supposed to be before the other one, but I think it's okay. We did it twice, kind of the same thing. And this is the last problem in today's lesson for sure. Yep, we have to given again that AB congruent to AD, BC congruent to DC. So again we have a kite. We need to prove that angle, in fact angle B it's congruent to angle D. Okay, yeah, that's the way, and these two angles are not congruent. Okay, so let's take a look first to the first part. Okay, so we're gonna go in these two triangles, ADC and ABC. When we notice, I already marked that AB, it's congruent to AD, and that is given, right? BC is congruent with DC. And that's also given. And then AC congruent with itself. We did that, I think this is the third time just in this lesson. And that is the reflexive property. So based on these three statements, what can we say? That these two triangles are congruent. Triangle ADC congruent with triangle ABC. Be consistent when you write this statement, and this will be based on side postulate. And from this one, yes, the corresponding parts are congruent, and the corresponding parts are angle D congruent with angle B. And that will be corresponding parts of congruent triangles are congruent. Now let's take a look to the last statement here that we need to prove, this one, which says the angle DAB, which is this gentleman, is not congruent with this one. They are different. And let's take a look. We're going to take a look to half of them, right? So if we take a look to this angle and this angle, for example, they are not congruent because the sides are not congruent. So basically that's my way of doing now. Statements, reasons, and I'm gonna say here AD is different, is not congruent with DC. And that is based on, maybe I should have write these two given statements. Okay, if these two sides are not congruent, the opposite angles, which angle DAC is not congruent with angle DCA. And this one is the theorem that says inequality in triangle, right? So I'm gonna say here opposite sides are not congruent. That is an inequality in a triangle. So that's the reason for this angle not be congruent. Now we can multiply by 2 each side. In fact, let me write it like this. The measure of angle DAC is not going to be the same with the measure of angle DCA. Okay, and this one will be not angle not congruent, then different measure. Something like this is the reason. Okay, and then we can multiply by 2 each side. 2 times the measure of angle DAC should be different than 2 times the measure of angle DCA. Multiplication property of equality, of inequality, in fact, now. But twice this angle DAC will be angle DAB, and that means it's not equal to the measure of angle. Twice this angle will be angle BCD, and this will be, I will say here, we can use substitution property, or in fact the angle addition postulate. Because we add two congruent angles, two angles that have the same measure. So now we really prove that angle DAB is not congruent with angle BCD. And that is different measures then angles are not congruent. So the converse. Okay, so I think this is all for today. If you enjoyed this lesson, don't forget to click the like button and come back on C-Squared for more help. Thank you.